very pleased to introduce you the first speaker. It's Adream Blair-Early, who will talk using interdisciplinary and active research to encourage higher resolution research on prototyping in design studies. She is actually an associate professor at the University of Wisconsin, and she's dealing in education with design and all the collaborative multi-level topics. Please. Thank you.
Okay, so I will time myself so that I don't go long. But thank you for the introduction. So my name is Adream Blair, and I'm associate professor, as he said, in art and design at the University of Wisconsin-Milwaukee. And we have a program of about 300 students, although at any given time we have 100 that have been accepted into the traditional design program. So they go through a portfolio review after taking initial design courses. And the program started out as a traditional design program. I'm not sure how aware you are of design programs, but they did interactive work, they did posters, they did branding, they did marketing. And in the last 5 years or so, we've been pushing our students and changing the program and changing the dynamic. And so our students are getting different types of experiences. And I teach primarily in universal design and in a new program called digital fabrication and design. We do not have an industrial design program. This is not an industrial design program. But what we figured is our students need new types of experiences to keep them sort of competitive and to keep them interested in the field of design in a broad context. And then we have an entrepreneurial section of our students, and they take courses in entrepreneurialism, in sort of patenting and licensing. They're expected to come up with ideas. So we give them two sort of really broad experiences beyond the traditional interactive and print campaign sort of things. The other person who's researched this who isn't here today is Frankie Flood, and he actually comes, again, as an associate professor of art and design from jewelry and metalsmithing. And Frankie's really cool. Frankie builds motorcycles from scratch. He builds these really rock star pizza cutters. He's a traditional artist who has an incredible knowledge of materials, material studies, and he can build anything. I've never met a person who is more capable of fixing and building something than Frankie. And so he came to us from jewelry and metalsmithing. He also teaches in digital fabrication and design. And what we started to do together is we teach these courses broadly under the terminology of universal design. So the first time we ran the courses, we did aging in place. And so we looked at developing items and ideas and products to help people age in place. So people don't have to move out of their homes earlier than they would like to. So the idea was, how do we get design students, how do we get design, engineering, and health studies students all working on the idea of developing ideas for aging in place. This is going to talk a little bit broadly about the idea of having interdisciplinary design education, but it focuses primarily on a project that we ran for the very first time last semester, and it was a project that actually started at Christmas time. We got a random email from a mother whose daughter suffered, I guess you would use the word suffered, from amniotic band syndrome. And so she was born without the fingers on her dominant hand. And she had read in a science magazine about them 3D printing hands. And so she asked her mom for Christmas if she could have a 3D printed hand. Her mom found Frankie through a blog online. Frankie came to me, we turned it into a class, and it became this really rich sort of experience for our students, and it opened up all sorts of questions about not just design and interdisciplinary design, but about sort of open source design and open source education. So there's a little bit of all of that in there. Oh, I switched to
Yeah, that's.
It'll still work?
Yeah, I have Macs.
Oh.
If you want, if you plug in USB, you can use it to advance the slide. So you don't have to search all that.
I've never used it, so there we go. So the first quote that I put in there is from Paulo Freire. Okay, is Paulo Freire, and the teacher is no longer merely the one who teaches, but the one who is herself taught in dialogue with the students, who in turn, while being taught, also teach. They become jointly responsible for a process in which all grow. And that's sort of become our mantra in not just this course, but in the design and digital fabrication program. So we're learning together. And in the interest of fair knowledge, all of this information and all of this new knowledge that I gained happened since December. I'd never 3D printed before December. I'd never taught a class on 3D printing. I had some knowledge of 3D programming, but other than that, this was all new. So it was kind of an interesting learning lab for both the teacher and the students. It was scary for all of us, but it worked. The reason we started talking about collaboration and building these programs is we have an increasing buffet-style course offering, so we were having courses that students would kind of pick and choose from, right, to complete their education, and that's not necessarily building upon skills. It's not talking about larger contexts and larger things that are going on in design. We had the increasing need to address new technologies. Design is a really difficult area because our technology changes in the space of a year. Not just new releases of programs, but now programming is moving at the speed of light. So by the time you've learned something, it's moved forward to the next thing, and we're constantly adjusting. There are very tight budgets, and we have a need for course flexibility, so our courses have to do more. So in order to keep those courses on the book, right, we have to fill them with at least 16 students at this point. So if we do not have 16 students in our class, we can't run. And a lot of courses that were important and integral courses to the design program have been sort of cut because we weren't able to get that 16 number in there. And then we had an increasing need for entrepreneurial students with knowledge of technology, critical thinking, and manufacturing processes. And it's done this switch. When I went to school, I learned about design, I learned about Big D, I learned about audiences, and now it's come back and they're saying it's not enough for you to know that. You also need to have an integral knowledge of manufacturing. How are these things being made? And increasingly, it's not just understanding paper and printing processes or digital technology. So why did we start collaborating? We wanted to offer increased student responsibility in learning. So now they're not just responsible to turn something into me. I have a tendency to be a mom, right? I have a 5-year-old, so I'm used to dealing with a 5-year-old. So sometimes those 18-year-olds come to me just like a 5-year-old. I think this, I think this. So it was great to put that added responsibility of their classmates and user on them, right? And the instance of Shay, it was this incredible thing because the students took this serious. They were creating something for a little girl. They met her. They met the entire 3rd grade of her school, and they took it serious. And it was this really beautiful thing for them to see and continue to challenge themselves based off of that. The necessity of ideation and prototyping and give and take. The necessity of connecting to diverse disciplines. So none of us went to health sciences, right? None of us are health scientists. We had health scientists in the students, or in our student body of the classroom. We had professors that would come in, but we had to connect to different disciplines. To broaden the classroom dialogue, again, having an engineer tackle a problem at the same time as a designer. They come at it from completely different areas. And then to allow students to experience as both user and colleague, right? So they were actually making hands and trying them on. They were fixing things. They were realizing certain things that weren't working. And then also to develop sort of a body of colleagues. The engineers tested them differently. They tested them for how long they lasted. They tested the materials. They wanted to know the efficiency of what we were printing with versus the designers who were really interested in giving the kids the crazy color combination and beautiful hands that they wanted. So it was a really interesting dialogue. So in short, we want to expose our students to real-life situations and users in order to facilitate the storage and carriage of the practical experiences into the future. So we want them learning through doing. So broadly, design needs additional testing, material studies, project-based work in our curriculum. We don't have enough of that. It doesn't exist. We don't have the luxury of having specific courses that talk about testing or material studies. We have to work that into our curriculum. Engineering and health sciences came to us because they needed creativity and problem solving. It was funny, there was a video that was posted about our project, and almost immediately someone said, well, surely engineering was part of it. And they weren't part of that first part of the study, right? And they came in, and engineering came to us, and they said, well, how did you get students working on this? And we said, well, we just tried it, right? We had that idea, we decided to go forward, and engineering and health sciences both wanted more creativity and problem solving. They wanted more iteration, right? There's always an end goal in a lot of their projects, and they wanted more user knowledge, right? So designers are still very in touch with who is Shay. She's a 9-year-old little girl who wanted fingernails, right? She didn't care if she even used the hand, but she always wanted to be able to do both hands for her nails. designers understood that, right? The engineers understood something entirely different. So it was this really beautiful collaboration. So Frankie and I are hoping to change how we teach design, and then we're hoping to change how we create our designers. So that starts with changing the design curriculum. Our mission is to develop and implement a unique curricular program that trains our next generation of technology, design, and business leaders to generate new innovative products that will promote and strengthen the national and regional economy, which is a big deal in Milwaukee right now, right? We have a struggling regional economy, as well as better the lives of the local and global communities. That's something that both Frankie and I, that's what we bonded on initially. We see college education as a beautiful place for students to engage in that kind of study, for them to engage in the community, for them to work on projects that are about social good, right? It's kind of a slightly insulated space for them to make mistakes and for them to create these really wonderful collaborations. And we also believe that the university setting should be open source. So all of the information that we're getting together, we're putting together in booklets, a series of videos, we're putting it all together so that it can be replicated. We're helping other countries replicate our studies. The idea is that we don't want to own this, we want everyone to own this, including the students. And that was a really difficult concept for design students who own their portfolios, who own all the work that they do. So we're always evaluating each course that goes into the digital fabrication design on creativity and design process, our methodology fabrication and material studies, on the idea of actual product realization, and then innovation and commercialization, and in this case, an open source. So some of the things that we're doing in the design curriculum is we're going from discipline-centric to interconnected, right? We have architecture courses, we have courses with health scientists, we have courses with information studies and library sciences, we have health sciences. We are completely inclusive. We want every type of student in there because we feel that it generates new ideas. We want it to be sustainable, solution-centric, and cooperative. And that we're going from this limited design to a global design process. And what we mean by that is we use J. Christopher Jones a lot in his hierarchy of design problems, and in particular in explaining it to students. And we talk about solving design problems at the systems level or the communities level rather than a component or an artifact, right? So rather than asking them, you're designing a poster, we say this is the larger community problem. Who does it affect, and how do you create a solution that addresses all of the people that it's affecting? So this just talks about that. It goes from component, product, system, and community. So in something like transportation, a component might be a shoe or the wheel of a car. A product might be the car itself. A system might be an entire line of cars. But when we talk at the community level, we talk about the roads and what it means to have an interstate cut through a community, right? How big is this problem? And it's a good idea to look at the problem in its entirety first. Contemporary design problems are solved at the community and system levels, not at the levels of products and components. And again, that's why we're continuing to move away from that in our design curricula. But even our design curricula 5 years ago was on products and artifacts. We had web design. We had interface design. We had app design, right? Poster design, typography. But we didn't talk about universal design. We didn't talk about the concept of aging in place and what does it mean to have grandma be able to stay in her own home, right? How does that change the entire dynamic of family? So our research, we use a framework of design research that is iterative, collaborative, and self-evaluative. We use participatory research, ethnographic research, and then materials and testing and product realization research. So participatory is iterative. It balances collaboration and data-driven analysis. We put in here, I put that reflective is important. It's collaborative inquiry. We're all asking the questions together, right? It requires reflective practitioners. One of the problems that we actually had in our class is that because technology was such a learning curve for us, all of our students, none of the students in our class this semester had ever taken a course in 3D programs, right? None of them had ever touched Rhino, none of them had ever 3D printed, none of them had ever 3D scanned, right? So a lot of them had never used a screwdriver, right, or a drill, and we had to use all of those things. And so we didn't have as much time for reflection, and so what I'd like to say at the end is, you know, how we're moving this forward. It's participatory problem solving. Nobody owns a specific piece, and then it's self-evaluative. I'm going to hurry up through this. Ethnographic research, we want the students to understand A lot of it's in observation, but it's also about participating in rituals. So we had students going and using the monkey bars. We had students who were part of the 3rd grade class. We had students who began to understand what the broad implications of a little girl's hand might be. And then I just want to point out that our research is not quantitative, quick, it's not replicable, and it's not based in large quantities, right? It's based off of observation, it's time intensive, it's interested in depth over quantity, and it's interpretive, right? So we have qualitative data, not quantitative data that we're going to talk about. So our space, and this is where it'll go really fast, is we've developed a space for digital fabrication and design. Each student has access to digital workstations and programs, and that includes 3D Studio Max. There's a whole host of 3D programs through Maya that we have access to. They have hand tools, machines, and machine and woodworking materials, 3D printing and scanning, laser and vinyl cutting. So this is one of the classrooms. We have a clean room and a dirty room, and this is our clean room, right? So you can see computers. They have workstations. It's actually changed quite a bit. The whole room has become really beautiful, showing the potential of all of the materials. But students have access to the computers. We actually have 3D mice now, which are really interesting because they sort of follow your movement. If you want to go up on the mouse. It's very, very interesting. And that's another view of it. We have vinyl cutting, so students use that for all sorts of things, right? They were etching plexiglass. They tried things. We have a laser cutter, which we use for everything, including Christmas ornaments, right? It's very simple. This is Rhino, right? This is 3D Studio Max, so you can see they have access to some of the 3D work. We do have 3D scanners. We have a high resolution and a low resolution handheld one, and it just creates low poly images that can go directly into Makerware, which is powered or part of MakerBot, and we use that because it's incredibly simple and it's completely compatible with the designer experience and how they design. So that's actually Frankie Flood. He doesn't have a mohawk, but when you do the 3D scan, it does crazy things to the top of your head because you're not scanning that. And that's him being printed as a little bust in the MakerBot. We have 5 MakerBots, 2 Form 1, which is a resin-based 3D printer. We have 1 laser. Again, this is an art class. It's just a dirty, fun room, but what we're doing is we're giving them higher and higher resolution prototyping ability to see what they can do with it. So going to Shay, and I put all these others because we actually have now, I think, 13 kits that we've made hands or are making hands for at this point, local and international. Haley is in Scotland, and they range from 3 years old to 13-year-old, both female and male. We're talking to the VA Center because they have some interest, and again, we do this as a free service. We don't charge anyone anything. We've been covering it out of pocket and through student fees for the classroom. That's Frankie. This is Shay and her little sister. We made the family part of the process. Again, that's about being collaborative. Mom and dad have a journal. They talk about what works for their daughter, what doesn't. We also gave both sisters a journal that they kept notes, and they drew pictures, and they told us what they liked, what they didn't like about it. It's the 2 of them. We 3D scanned them. We took them through all the technologies that they would be using. The first thing that we did was paper and pencil, and we traced her hand. We had no idea what we were doing. We were following anything that we could find online. So there you can see Frankie's 3D scanning her affected hand. That's her affected hand brought into Rhino. There's our drawings of her, so you can see what that let us do is let us fit the 3D pieces on top of it. We could check finger length. That was something that she was really worried about. She's a 9-year-old little girl. She's very aware of her body. She didn't want a giant, monstrous hand, which she was really concerned about. We were stuck a little bit making it larger than that. We created a mold, and I brought that in. So this is she's a little hand right here. So that's our model. So there she came out. We tried thermoplastic, right? We didn't know. We actually downloaded a little pamphlet from the 80s and called a friend from Health Sciences and said, we're going to make some things out of thermoplastic. What should we know? And they said cornstarch and make sure it's not too hot. And that was it. So we created molds. Here's our graveyard. We probably have 1,000 dead prints, broken prints, outsized ones that are just laying around there littering. Right now, that was Shay's very first hand that we created for her. It was based off of Jorge Zuniga from Cornell, I believe. I don't know, Creighton, sorry. And he created the Cyborg Beast hand. We made adjustments to it in order to change size. We've made several adjustments since then. Again, put them right back out. This is actually based off of the Talon. This was Shay's hand. She's already outgrown this hand. But this was her design. We let her pick colors. We printed it in different colors. We laser etched the leather, right? So we made this something she wanted hearts. She wanted swirls. We tried to make this something special, right, that she would want to wear. So again, this was one of the first hands that she received. She got to use this until she actually outgrew it. I'm sorry. That was just my tongue. Okay. No big problem. Sorry. So that's front and back. So this is the first fitting of it, right? So she's trying things, she's picking things up. And I'll just share with you really quick right here. This was the very first time that she tried this handout, and this is the very first thing you'll see. She jumps and she picks it up.
Oh,
She kind of gets excited. That's the very first time that she picked something up, and it was incredible to have the students share in that. Again, that's where the students became really invested. This was a 9-year-old girl, but they saw the first time she picked up something with her affected hand. I'm almost done. So, student explorations. The students started, again, they're designers primarily, whether they're engineers or they're in art. So they started out with sketching. They did analysis of hands. They looked at designs. This is them in the space. They were playing with existing designs. Some of the things that you can see is this is actually, I mean, we use really common materials when we're making these, other than the leather. The cord in these is the cord that you use for your window blinds. The plastic pieces, which you can't really see that are hidden a little bit right here, are the stretchy cords that you use on bracelets that you buy at Michael's. These D-rings, I couldn't find the right size, and I stole them from my daughter's shoes, right? So, which was really difficult, right? We had to figure out all of these things, and the students did that. So what we found was the initial design, she couldn't grip things. And so one student came in and said, let's try tool dip. And so you can see right here, the black on the fingers is tool dip. They've let it dry, and now they're testing to see how well it folds. This is a student design. This is really interesting. This is based off of the Bob Roth hand, who was a machinist who was a finger. It's a fully articulated finger. It's incredibly interesting. But what she was trying to do is do a print in place. So every single, like this actually has 128 pieces in order to make this work. And each piece is separated, and they're strung together, and they're held together. She tried to create a finger that when you printed it, and she was actually successful, but when you printed the finger, you cracked it, right? And you cracked a couple supports, and then it was fully usable. So you didn't have to put those things together. Incredibly interesting, beyond the scope of what I could personally handle, and that's the excitement of working collaboratively with your students. So her hand also uses a wrist motion so that you can move the fingers independently. Students explored cork because they didn't like the heaviness and the weight of the leather. This student actually created a whole snap system. We learned about snaps because he wanted them to be able to pull the hand off and watch Shay. And it was a big ordeal for her to take it on and off. And in the winter, when she had to take her coat on and off, it meant that she didn't use it for a good chunk of the time. So observation was really important. This is really dark, but this is a student who created a series of covers, right? She was into costuming. And she made Warbler and leather covers for all the pieces, and this is just shown on a hand right now. But she etched them, put them together. They're incredibly interesting. This was another student who was really interested in someone who didn't have a wrist, who one of our students now is working with Bella, who's 4, who has a wrist, but has almost no palm. So it's incredibly hard to fit her in, so what we need to do is use something that goes up further on her arm. So he created one without a wrist piece, and you can actually see his initial prototype. I promise I'm almost done. So you can see he's got a band that he created across the arms, and you can see the fingers are moving independently. He doesn't have them all strung in this video. This was just during class. But again, students tackled things that I hadn't tackled. students looked at things and were based off of observation. It was working with the other engineers and health sciences, and they got to really exciting examples. I should also point out that all of the students in this class, with the exception of 2, were sophomores, and we had 2 juniors. So these are young students, right? These aren't seniors who've had a ton of experience behind them. Okay. I actually agree. My favorite are sophomores. So last but not least, what we did to move forward, right, because this is just the start of our journey. We just finished in May. Like I said, the request went out at Christmas time, right? So this is Kayvon. He was in the class. He's working all summer. That's Bella, right? Her affected hand is behind her. She's the one who's missing a palm. He's actually working with her. So now what we've done is we've turned our students into the teachers. We also have a group of high school students that are coming in and taking a high school summer course. It's fun. The students are teaching the high schoolers. And then we've given students the chance to meet the kids that they're creating the hands for. And now they have that responsibility. So he's working along with another student on Bella's hand. Here's for a boy who's, I believe, 11 in Colorado named Kai, right? That's John. So each student is starting to create their own. I'll finish on this just. So the other thing that came up that was kind of interesting on there is, so this is a video of one of the boys. Almost all of our kids that we've worked with so far exclusively have been kids that were born with the condition. They were born missing fingers. And so there's a novelty aspect in almost every single one of those cases for this, right? They don't need it. Shay lived 9 years without it. She's incredibly independent. She rock climbs, right? But without her hand. So there's a novelty, a toy-like aspect to it. Evan lost his fingers in January. He's in northern Wisconsin. He lost his fingers to a snowblower issue. And one of the things that we found that was really interesting is this is Evan using his hand, I think a couple of days after he got it. And I'm finishing it right now. And what you'll see is that he's incredibly, maybe it won't fall there. But he uses it quite different. He really throws. And he's using his hand because he grew up with that hand, and it was his dominant hand. So we're excited about these possibilities. We don't know where it'll all go. But that's my presentation. I'll leave it on Evan, and we'll do questions at the end. Thank you.